first up, so that you can kind of sort of graph these guys by hand, there's going to be 3 points that I want you to apply. Okay, the 3 points that you can apply to every exponential function pre-shift are 0, 1, because when I take any number and I raise it to the 0th power, I get 1, right? 1 comma, if 1's my exponent, what happens when I raise something to the first power? What do I get? What's a to the first power? And then the third point, when I raise something to the negative 1 power, I get its reciprocal. So we can say like 1 over a. I'd rather say the reciprocal of a, because sometimes your base is already a fraction. Like what we saw with the 2/3. I don't want you to tell me that it's at negative 1, 1 over 2/3. Just give me the reciprocal 3 over 2. Okay? These are all points on that graph. Okay, next up. The domain for every exponential function is all real numbers. Okay, as long as I have a positive base, I can plug in any number I want. I can raise it to any power, including pi. Okay? The range is always going to be 0 to positive infinity. It's always going to be positive numbers until I get around to moving these graphs around. Okay? This is just plain old a to the x power that we're talking about, right? Okay? If, you know what? I want to ask you guys this. Delete, delete, delete. There's our 2 to the x function that we graphed, right? Here was our 1/3 to the x power that we graphed. What was the argument, essentially, for why 2 to the x was an increasing function and 1/3 to the x was a decreasing function? What about those numbers made them increasing versus decreasing? Okay, that's a good postulate. So let me turn these off. What if I did 3 over 2? That's a fraction, right? But is this going to be an increasing or decreasing function? It's a fraction, so why is it increasing? Say what? So what? What does it say about that number? What? There we go. The base here is bigger than 1, right? 3 over 2. Because the numerator is bigger than the denominator, we get something bigger than 1, right? And when I multiply numbers that are bigger than 1, don't I get a bigger number? But when I multiply by things that are less than 1, I get smaller numbers. So this is what determines whether our function is an increasing function or a decreasing function. If the base is bigger than 1, then we have an increasing function. In fact, it's going to look like that sort of. I mean, you know, maybe a little sharper, but that's the idea. Okay? If our base is in between 0 and 1, if it's a relatively small number, if you have a small base, then you get a decreasing function. One that's going to look like that. And last thing. The asymptote we mentioned. Okay? These guys are going to have horizontal asymptotes. And as long as we haven't moved this graph up or down any, that horizontal asymptote is going to be your x-axis.